Hey, what's up, people? We've got a long one today, and I don't mean in terms of video length because I really don't think that this one's going to be very long at all, but I don't know. I've been wrong before, so I guess we'll see. This is a Herman Miller branded LED light bar, and if we take a look at the label underneath, it says Herman Miller Twist LED Under Cabinet Light, suitable for under cabinet mounting, if the name wasn't obvious enough. I had never actually seen one of these before, and I didn't even know they existed. But a friend and I were recently helping out another guy that we know move out some stuff from a shop that he was closing down. He had like a stack of stuff, and he said, if we wanted to rummage through it, if there's anything in there that we wanted, we could take it. I saw this light bar in there, and I saw the two LEDs, and it caught my attention. So I snagged it, and unfortunately, one end is kind of loose, and it looks like the retainer for that end is inside of this end cap. So we'll have to remove it and see if we can, put it back on. But since I had to open this, I figured we can take a look inside to see what's going on in there. And the reason it's called twist, apparently, is because on the ends, we actually have two magnets. So if you attach this to like a magnetic, or not a magnetic, but like a metal cabinet, would stick to that. And then you've got this small tab that you can actually use to kind of redirect the direction that the light's going in. And they had to brand it there, make sure that when you turn it on, you know that it's a Herman Miller product. There's a label down on the bottom side that says a model G6160.AM. It's got a day code of, I'm guessing, 31st week of 2015. It says the power supply input is 100 to 240 volts AC, 0.5 amp, but that's talking about like the actual power brick. This lamp actually uses 24 volts DC at about 0.355 milliamps, or 0.355 amps, which would be, 355 milliamp. So on both end caps, there is a barrel jack. As we can see, there's one on that end, and there's one on this end. So you can plug in power from either side, or I don't know if maybe you can daisy chain these. Maybe not if the power supply doesn't provide enough current. So it just gives you the option to either put the power supply on this side or on this side, and then that way, it doesn't matter too much where you mount it. The power cord is not going to be that big of a deal. Now, the funny part is that I did not get a power supply with this when I grabbed it. It was just chilling in there in the stack of stuff. And I honestly had no idea what the power supply for this even looked like or anything. And I thought, well, I can just find something that has a barrel like plug that'll go into that jack. And then, it should be fine as long as I can provide like 24 volts at a decent enough current. However, I decided to look this up on just kind of Google it. And I saw some pictures of these with the power supply. And I thought, wait a second, I think I have one of those. And sure enough, I went through looking through my box of little random power supplies and stuff, and I have one. It's this plug that goes onto the end, like either end, and it's shaped just right so that it fits on the end like that. And then it actually has a little toggle switch right there that you can, use to turn on and off. So I'm guessing that this probably maybe had like some tape there at some point. You could mount this, and then you'd have access to the switch, wherever you wanted. Now, the same friend that went with me when we went to go help this other dude move is one that had given me like a box of stuff one time. And I believe this power supply was in there, and that's where I got the power supply. So a total coincidence that I ended up getting the lamp for this power supply eventually. And I'm kind of glad I didn't butcher it, because at one point I was going to cut this off and just use this power supply, because it is a 24 volt power supply, use it for like random stuff. But I ended up leaving it intact, and I just kind of threw it in a bin with other power supplies. So I got the entire set now. So getting inside this thing should be fairly easy. We just need to remove these screws on the ends holding the magnets in place, I believe. So let's go ahead and remove those and see how far that gets us. I think if we remove like this end, then it should allow us to pull the cord out from the other side. And so that removes this outer sort of covering. The magnet is attached to this metal plate. I don't know if it's actually glued or if it's just stuck on there like magnetically, but we're just going to leave that intact. There's no point in taking that apart any further. Okay, so there's the nut that's supposed to hold this end in place. So that should be really easy to reattach. This barrel jack looks like it'll just pop out of, or can we slide it forward? Ah, okay, there it goes. Just had to pop it out anyway. Okay, and it does not appear that I'll be able to, well, actually it doesn't matter, because I can just slide the entire thing out now. Everything should slide out from this sleeve. There we go. So yeah, everything just comes out this way, or either way, just depends on which side you take off. So yeah, that's just the metal cylinder housing everything. You can see we've got a groove up there for the clear lens. So we'll just set that aside. And there we are. So we've got these two aluminum blocks that the LEDs are screwed onto that act as heat sinks. And there's a small board right in the middle. Doesn't appear to have a whole lot on there. It does have, and it looks like an IC right there. We'll look at this closer in a sec. But so yeah, both ends coming in. They're connected in parallel. We can see that they both go to the same spot right there on that board. This piece in the middle is just plastic holding the two aluminum blocks together. The screw on this side is all kind of loose, so maybe we'll give that a little bit of a tighten down. And some of these wires were left kind of long, so they had to twist them all together to get them to kind of stay in place inside. So I'm guessing they just probably had them like pre-cut. They just solder everything together, you know, screw it down, and then they just kind of tuck the wires wherever they'll fit. And there's plenty of room inside, so it's not like they're totally crammed in there or anything. All right, let's see what's on this board. And just from a general overview, we've got a MOSFET on that side. We can tell because it says G, D, and S. So that's gate, drain, and source. What is that? Oh, that's just a piece of solder. And we've got a jumper. That's a 0 ohm resistor. We've got R150. So that would be like a 0.15 ohm resistor. Capacitor. We got one diode. We got another diode right there. Looks like another resistor down underneath this wire. It's kind of stiff, so I don't want to like bend it out of the way too much because I don't want to break the or pull that pad off. And then we got another device. Looks like a, dang it, I'm not sure what type of package this is, but it's basically got a total of 5 pins, I believe. So it's going to be like 1, 2, and then the middle ones, I believe, are the same pin, and then the 4 and 5. And that MOSFET, it might be a T23N03. I'll have to look that up to check for sure. That other small device, that says 7136 and then 1512, but that might be a date code on the bottom. That resistor is a 5.1K resistor. That's a diode, that's a SS24. No idea what that one is. Little capacitor. The two LEDs, they're just the chip on board type. We can see that they're really kind of long rectangular ones with the screw mounts, and then they just have one terminal going to each side. Can't really see much underneath that phosphor. And this one, it looks like they didn't put very much heat sinking compound in the bottom of that one. But on the other side, you can see that it's kind of like squishing out. So they kind of went anemic on the other side. As you can see, I've pretty much almost completely reassembled this thing with the exception of that magnet. But I'm actually re-recording this because I realized that I didn't turn my microphone back on. But anyways, there's like this little fly buzzing around here. It's like bugging the crap out of me. Bugging. Anyways, so the little board inside was pretty simple enough that it was easy to reverse engineer it and make a schematic of it. So I tried to lay out the components the same way that they are on the board inside of the actual assembly. And so what we have is the big diode, the one that was the SS24. That happens to be a 40 volt 2 amp Schottky diode. And as we can see, that connects directly to 24 volts. After the voltage comes out on this side, that goes through a 5.1K resistor that we saw on the board. And it's connected in series with this other, it's actually a Zener diode, the one that was unmarked. And I measured the voltage across the two terminals from this pin and this pin. And when I powered it up, it ended up being about 5.1 volts. So it's pretty certain that it's a 5.1 volt Zener diode. And that's used to provide power to the 7136 IC. And I did find a data sheet for this IC. I found several actually, but they all had like different prefixes. But this is one of the better data sheets that I found. This was for an AMC 7136. And as we can see, it's an adjustable constant current LED driver. And so it kind of shows us like a little block diagram. And so we have a total of 5 pins on it. We have VDD, DR, LED, CS, and ground. This shows an EN pin, but this pin is not available on the actual package. So maybe there's like another version or another package that has it, because this is what ours looks like. And as you can see, there's like no EN pin anywhere on it. If we look back at the block diagram, we can see that the LED pin is going internally to a FET inside the IC. But we're not actually using this pin because the voltage requirements of the LEDs that are inside of this lamp are actually higher. So what they're doing instead is they actually tap off of where the gate would be for the internal FET, and they are bringing it out to the DR pin. And if we look back at our schematic, That's pin number 4. So that goes through a 0 ohm resistor. And the only reason this resistor is here is because there's a trace that goes underneath it. So I just kind of left it in there just so, we could see how it's actually everything's like wired on the board. So that pin goes directly into the gate of this NTD23NR03 MOSFET that we saw on the board. And the source of that goes directly into the 0.15 ohm resistor. So this is a resistor that's being used for current sense. That goes into pin number 1. And if we look at the data sheet, we can see that 1 is the current sense. And there is a typical applications little schematic that we can see. This is basically what we have on the board. So that's our current sense resistor, that's our FET, and that's our LEDs connected in series. We can see right there VDD goes to the Zener diode and the resistor. So we saw how that's implemented on this board. And so we can see that everything on here pretty much matches exactly what the applications note has on it. This is the capacitor, and that's just used to stabilize the voltage on the Zener diode going into the IC. So I couldn't measure that. So it's like, whatever. It's just, there's a capacitor there. You know that. The only other thing I did was that I actually pulled one of the wires going to the strings of LEDs off the board. And then I stuck 2 leads and I clipped them onto so that I can measure the amount of current that these LEDs are being driven by. And once everything warms up and it's kind of like settled down, it sort of settles at about like 303 milliamps. And the MOSFET itself actually gets pretty toasty. It gets in like the high 70s, about like 80 degrees C. And if I like blow on it to kind of cool it down a little bit, the current going to the LEDs actually increases a little bit. So as that MOSFET is getting hot, it's not allowing as much current to flow through the LEDs. But since that IC inside is kind of, controlling everything, it doesn't look like the brightness like really varies much or anything. So like any changes are, at least not to me, they weren't like all that noticeable. So yeah, that's pretty much going to do it. I reassembled it. On the end, there is the nut that holds everything together. One thing I hadn't noticed until I was about to put it back together is that there's actually a wavy washer that sits in between this washer that actually kind of like locks into the aluminum that the LED is mounted to, that threaded portion on the end. It locks onto that so that it keeps basically everything there from turning. Although, as you can see, that wavy washer still sort of moves a little bit. So I think with like repeated motion of like moving back and forth, that nut can get loose. I kind of tightened it up to the point where it shouldn't be a big deal. Like maybe it won't loosen up too quickly. But I mean, that's probably what happened and to this, and that's why that nut had come loose. Just maybe the motion, like continuous motion back and forth, loosened it up to the point that it just completely came off. But there it is. That's all back together. And as far as the magnet goes, it turns out that they are 2 separate pieces. This is not glued on, so the magnet can just be like slid out. And I took them off because there was a bunch of like little metal bits of debris on them, and they were all, like gritty and grainy from all the metal there. So I cleaned them off, and I can slide them back on, and then, I can put this back on, and it's all pretty much done. And there we go. It's all back together. I actually kind of like the light that this thing produces. It's actually pretty nice. I'll just have to figure out where I can mount it that it would be useful, but it's not like bluish, and it's not like too like warm white. It's just kind of how would I describe it? Kind of like a neutral, like sunlight maybe? I'm not sure. I guess I could probably look up like some specs and see like, what sort of like color temperature it's supposed to be. But yeah, that's going to do it for this one. I actually had like a totally different video planned for today, but I ended up having to order a part. And so until that comes in, I can't finish that video. So I ended up doing this thing because I just happen to have it on hand. And yeah, that's going to do it. So it's Mother's Day weekend. And if you're a mother and you're watching this, happy Mother's Day. And for everybody watching, thank you for watching once again. And I will see you guys around the bench.